I'm with TJ Kniveton. He's the VP of Infrastructure Engineering at Salesforce. TJ's just come off a really interesting panel looking at how software-defined the data center actually is. Lots of interesting information. Something kept on cropping up. It was a terminology, and it was SKUs. SKUs. I wonder whether you could just explain what an SKU is and what it means to you and what it means to data center and capacity.
Sure, yeah. So SKU is a term from the retail industry, and it stands for stock keeping unit, and it's essentially an individual identifier of a thing. The way that we use it in data centers and data center infrastructure is around server SKUs, which really means a server configuration. So in hardware engineering, what we talk about is a server platform, which means essentially a manufacturer's model. So you have like an HP DL360 or a Dell R720 or something like that is the platform, and then how many disks do you put in it, how much memory does it have, how is the BIOS settings configured, all those things make it into an individual SKU. Sometimes we talk about it as a BOM or bill of materials, but it's essentially the server platform plus the sort of options and configurable characteristics and the configuration of things like power settings would turn it into a SKU. Why is this important to us? Well, one of the things that's really critical as we start to get into really hyperscale and scaling up to web scale systems is consistency and making sure that the software can easily control the fleet of hardware and servers. And so the enemy of consistency is something called SKU proliferation. I can't even say it. SKU proliferation is an artifact of the way things have been done in the past, where each server is sort of bespoke, configured for exactly that application. So for Hadoop, for instance, you have a whole bunch of spindles, maybe depending on how much you're actually analyzing your data, either medium or powerful CPUs for those servers, and a specific amount of memory. For a front-end application server, you may have almost no disk, just enough for the OS, but you've got great network interfaces and maybe a lot of memory. And so what has happened is in the enterprises, we have a whole bunch of different applications. We've configured all these different server types to really be optimized for the application workload. As we get into larger and larger scale and web scale, we move away from that and we move towards something where, for us, it's what we call single SKU, which is we want everything running on one compromise SKU because it gives us really powerful side effects in terms of fungibility of resources, so that if one of 50 applications has a huge surge and 30 of them are fairly idle, we can actually autonomously, through our control system, remove those servers from those applications and reallocate them in minutes to the application that's having a surge. And that comes from homogeneity, which is the opposite of SKU proliferation, which is why we talk about it.
Now, do developers dislike the fact of going to a single SKU? Because before they had the ability to go and work with different machines and spin them up how they wanted and write different bits of code. Right. Now you're talking about this more homogeneous.
They have to adjust, for sure. It's an adjustment, but I think after the adjustment happens, there's some really amazing benefits that they get out of it. And in that sense, when you have a specific application workload, let's say it's a disk-heavy workload, and you're used to having 12 or 18 spinning disks in a server, and now you're going to a server, maybe a 1U server with 4 disks. You might not like that because you're like, well, my application instance needs a whole bunch of IOPS from disk, and it needs a whole bunch of storage for data. It forces them to think about scaling in a different way, so that you're not vertically scaling individual machines to be really powerful. You're horizontally scaling your application to use an arbitrary number of hosts. So let's say I have a disk-heavy workload that used to use 18 disks, or let's just say 16 for the sake of simplicity. Now it's using 4. So it's got a quarter of the disks available. But what if I can give you 10 times as many machines, right, to run that workload on? We can adjust the pool of machines to the application, and even if we leave certain resources unused on the server, that's okay. And it becomes even more okay as we start to use containers and sort of dynamic workload placement, because what we can then do is have our control system look at those 10 times as many machines, but actually introduce some memory-heavy workloads, other services running on those machines in separate containers, to scavenge all of the stranded resources that we've distributed amongst those 10 machines. Instead of having one, which is somewhat inflexible, which we can't reallocate to other services, we've got 10, but we can put other services on them, we can move things around, and they become part of a really large pool where when this application doesn't need as much resource, we reallocate it to something else.
Thank you very much, TJ. That was a great explanation.